So let's go over how we would do these. Number one, the first question, I'm going to plug g of x into f of x and simplify. If I get x, then I have an inverse. If I get something different, it's not an inverse. And so if we kind of work this out, you can see it on the screen. So let's stop it right here. The first two were really simple. And like I told you yesterday, if you do the plugging things in back and forth, it should just kind of fall apart. So x plus 2 minus 2 is x. When I distribute the 5 from here into that, you're going to get x plus 1 minus 1 is x. All still inverses. We go to the next part. And I can stop right there. What is x cubed, or sorry, the cube root of x minus 1 all cubed? It's going to be huge. It's going to be a lot of different things that I really don't care to work out. That's the cube root of x minus 1 times the cube root of x minus 1 times the cube root of x minus 1. The only thing that I need to walk away from that with is the fact that it's not going to give me x. Even if it did, well, it's not going to. It's not going to cancel out. I'm going to get all kind of stuff. And you could try to even start doing that. You're going to realize, wait a minute, that's all going to mess up. Maybe you're not sure. Go on and try D. What's the square root of x minus 2 squared? What's x minus 2? Plus 2. Oh, that's just x. The only one that doesn't come close to that is C. So I get why you missed that one. I can see that. But it shouldn't have been that many people to miss it.
How do you get... Never mind.
Good?
Yeah, I was confused because I thought that the square root just went over the x. And so then it would have been the square root of 2 minus 2. And I got confused, but it's not.
Yes.
So never mind.
You will, listen, you will see these questions. Every day, I'm going to pick 2 questions from the benchmark that were most missed, at least for the next week. Okay? I'm going to put those up, and I'm going to put them on your tests. They're not going to be part of the topics that we're talking about. I'm going to put them on the upcoming tests, which is Monday. This coming Monday. As in, not a week from now. Less than a week. As in, the next Monday after Sunday, when you come in from the weekend, is your test. I've been saying it for a week now. It's also been on the calendar. 22nd sounds about right. Yes. I do not like to give you Monday tests, but I have a choice. Okay, today's review, tomorrow's review. I will not see you at Friday. Okay? I won't have any classes on Friday. So that means that I can't take Monday and shift it back yet again. I would love to have given you a test on Friday. That would have been the perfect day. But it's an early release day and I don't have time. So just think about it. Oh, I have extra time to study for my test.
Wow, thanks, Mr.
Here we go.
That's so nice.
Now, just to kind of go back over the next question, you've got the slopes. F of x equals y. That was the one thing you needed to know. If you go through that, you're going to have y2 minus y1 over x2 minus x1. That's been around forever. I just need to know, when I subtracted the x coordinates, I got 0 on the denominator. The only time that happens is when x is the same number. I look up in my choices, the only option I have is right here, 8 and 8. When I subtract, and I do all that work, I'm going to get negative 5 over 0, which means that number is not a number. It is undefined. Okay? Hopefully most of you got that right. I don't know. I haven't looked at all the different results. But let's move on to something new. Well, something old. Okay? I want you to try working on this one. Here we go. Watch. The first thing we're going to have to do is find the vertical asymptotes, and then we're going to find the x-intercepts. In order to get my critical values, which means when does the graph, when is it broken, or when does it pass through the x-axis? Right? Because that's those are the times that the graph can change signs. And right now we're looking to find when it's negative. How do you find vertical asymptotes? Set the denominator equal to 0. Good. How do you find the x-intercepts?
So it's the coefficients.
Set the numerator equal to 0. Okay, so if you do that, you should get those results. Plus, I want you to circle that plus or minus. Plus or minus. If you don't do that part, you'll miss a huge piece.
Is there not a y asymptote?
There is a horizontal asymptote, but I don't want it. Not for this. We're not trying to graph the function. No, the y asymptote here would be y equals 0 because the degree on the bottom is larger.
And then is the x-intercept to x equals -2, or is that another?
That's x-intercept. Shh. Okay? Listen. What do we do now? Plot your critical points. I've got -3, -2, and +3. You're going to pick a point in each section, and you're going to try and test them out. I want you to plug them in, I want you to test them, and I want you to write the interval that satisfies the original problem. All right, so look at the bottom. You should see your results just like this. And just for example, if you take 0 and we plug 0 in, we go up to the top, we plug 0 in here and here. That means that's going to be 0 plus 2, which is just 2, over 0 minus 9. So we're going to end up with 2 over -9. That value, that's what I see here. Positive result over negative means the whole thing is negative. If you plug in +4, it's pretty obvious you're going to get positive over positive. When I plug in -4, the top part's negative, but the bottom stays positive because you have to square -4 plus, and then you subtract 9, it's still positive. So that makes this negative. When I plug in -2.5, turns out that both values are negative, which makes the whole thing positive. So the question asks us, what interval makes this less than 0? Well, less than 0 means negative. So the two intervals I'm looking for would be between this number and this number, and then at this point and all the way to the left, right at the intervals that works for it. The question was, is it always alternating? And the answer is, it does not always alternate. Okay? When you have a polynomial, like x squared or x cubed, then most likely it could be alternating. But I wouldn't take the chance that it's not. One of the first ones we did didn't alternate. If you have, if the roots only occur one time each, like the degree for each root is odd, then yes, it alternates. But I still wouldn't play with that, because the asymptote, weird things can happen when you have multiple asymptotes. So I wouldn't trust that it alternates all the time. Here's the results. -infinity to -3, and -2 to +3. All of that gets parentheses. Why not brackets? Because there's no equal to part here. Okay? Let's go on to the next question. All right? Actually, we're going to skip that one. Let's do this one. Okay, take a few minutes. I want you to solve that one. First, listen. Let's walk through it. The first thing we do, even if you have no idea what I'm asking you to do, most of the time, like 99 times out of 100, we factor things. Just because that's what happens. So, when in doubt, factor. You factor that x out because it's common to all three terms. Then you're left with an x squared minus x minus 2. You realize that also factors. And so we factor that apart, set it equal to 0, and then we have our zeros right there. We have 0, we have 2, and we have negative 1. Set those on our number line. Shh, listen. Once we got them on a number line, I'm back to what I did before. I have to pick points in between, and I have to determine when is this greater than 0. If you have a graphing calculator, there's a lot of positive things that you can do to help yourself. If you want me to go through this on a graphing calculator, if you have one, then you can send me an email or you can come after before school. I'm not going to take class time because not everyone has one. Not enough people that doesn't warrant me to do it in class. But you're welcome to have the graphing calculators to use. In fact, if you don't have them, this kind of stuff, it's very useful. Okay, our next chapter, you won't even be able to use the calculator, period. Like, don't bring it. So, it's not going to be great then, but for now it's going to be really useful. Shh. All right, so I'm going to pick a couple of points. I'm going to pick negative 2. I'm going to pick negative 1/2, 1, and 3, and I plug those in. Turns out you're going to get this result. Is he putting you to sleep? Stop. No, your eyes are about to glaze over. Stop. Most people are going to look at this problem and think, okay, well, it's 3x plus 5 times the absolute value of x minus 2. If you take it apart and you do the traditional steps that we've done, I said, well, I need to find the zeros of this function. Where does it touch the x-axis? Not a problem. We can go through here and we can say, just like before, and we can work it out, and you can say 3x plus 5 equals 0, and x, the absolute value of x minus 2 equals 0. It's really already factored for me. I really can't multiply that together because of the square roots. One of those is really, really straightforward. One of those is not. Right? If we solve them, we're going to get these two parts. But, Mr. Wigg, you didn't do the other case 2 for the absolute value. But what happens? It's the same thing, because you're going to get negative x plus 2 equals 0. Or you could just say equals negative 0, but that doesn't matter. All right? The only number that I can plug in to this to make that equal to 0 is the number 2. It's when it's equal to a number not 0 that makes it a problem. When is the absolute value equal to 4? Well, the inside part could be 4 or negative 4. But when the absolute value is 0, by definition, what is absolute value? It's how far are you away from 0. Well, if it's equal to 0, you're at 0. There is no distance. So it can't be positive or negative. So the two critical points I have are there. All right, if I go ahead and mark those off, why would I only do 1? Will you stop for a minute? Shh. Hold on. Shh. Let's just for a minute look at the absolute value portion. Okay? I'll put a plus sign underneath that. Can I make that part become a negative number? No matter what I plug into absolute value. And you could have done this by testing points. For example, if 2, let's go ahead and add that. If 2 is my value, let's plug in 3 to this, just to this piece. What is 3 minus 1?
You mean 2.
3 minus 2, sorry.
1.
It's 1. The absolute value of 1 is 1. Let's plug in 0. Right? That's in between these two. 0 minus 2 is negative 2. The absolute value of negative 2 is positive 2. So if I were to write this down, that's positive and that's positive. Doesn't matter which side I'm on, because the absolute value function is always going to do what? It always gives you a positive result. Always.
So what if you have done
Shh. Which differently? Stop.
problem?
What? You've done it differently?
And I
Hold-
got the same thing?
It's very possible. There's a lot of ways to think about this one. Let's go ahead and finish it out. If I plug negative 2, if I plug negative 2 in here, what is that going to make my fraction? Or this part?
Negative 6 plus 5, negative 1.
So it makes it negative, right? So this part becomes negative. So if the absolute value part is always positive, then this function is going to be negative wherever the first part is negative. And so you end up with this result. X would have to be less than negative 5/3. Or, how would we write that as an interval? Good. You do. Just be negative 5/3, or negative infinity to negative 5/3 with parentheses. Shh. I'm going to change it. Shh. Any questions on that part?
Yes.
What's your question? Negative 2 is the number that I chose to plug in. Because negative 5/3 is 1 and 2, negative 1 and 2/3. So negative 2 is just past that.
So you worked out negative 5 and 3. You worked out 2, not negative.
Shh. I plugged in negative 2. I didn't write that part down.
No, I did 5.